Hello, y'all. How are you doing? We are going to start our last unit, Unit 9, which is statistical inference. This first video is just a little introduction, and we'll get to the math in the next one. But first, some vocabulary, and y'all know that in math, in statistics especially, vocabulary can make a difference. So what is statistical inference? Well, think about the word inference or infer. When we infer, we use evidence and reasoning to draw conclusions. So statistical influence, we are using data from a sample to draw conclusions about a population. And remember, you don't have to print these notes. You can write the sentences down. If I'm going a little faster because mine are printed, just hit the pause button, okay? Vocab is really a big deal in this unit, okay? So statistical inference, we use data from a sample to draw conclusions about a population. The basic strategy in statistical inference is to use a sample statistic to estimate a population parameter. Let's look at an example. If we were in class, this would be example 9.1 in your book, but it's printed here, so we're going to read it. How common is behavior that puts people at risk of lung cancer? In 2007, Youth Risk Behavior Survey, a risk youth behavior survey questioned a nationally representative sample of 14,041 students in grades 9 through 12. Of these, 2,808 said they had smoked cigarettes at least one day in the past month. That is 20% of the sample. This result may be biased by, okay, well, one thing, reluctance, to tell the truth, and that would be about any risky behavior or something you're not supposed to do. Okay, so our results could be biased. We don't know if they're exactly right because we're unclear or unsure if people told the truth. For now, we're going to assume people told the truth. Based on these data, what can we say about the percent of all high school students who smoked? And that's really what this unit is about, is you look at the data from your sample and then you say, okay, this is what I know about the population. Our population is high school students in the United States. So let's population. Remember, we have to keep sample and population separate from each other. Okay. All right. The parameter is the proportion that have smoked cigarettes in the last month. Parameter. Okay, we want to keep these words straight. Call this unknown parameter P, and that P is for proportion. Okay, the statistic, I'm going to change colors, that estimates the parameter P is the sample proportion. P hat. And if you remember back We looked at this a while ago. We never really know the parameter, right? We never know exactly how many people in the population are doing this or smoking or whatever the case is. We know p hat, which is the sample that we asked, the people that we asked. So we use p hat to estimate p because we want to know what's going on in the population. And that's what this unit is all about, taking this sample data and seeing if we can predict and figure out what's going on in our population. Okay, so we're going to talk about a new word today called confidence intervals. And right now we're going to focus on a 95%. We'll add to that in another day. Okay, a confidence interval is calculated from the sample data. What we want to be able to do is tell people how sure we are. It's like, I am 99% sure that this is going on. Okay, so that's the whole idea. So it's an interval calculated from the sample data that is guaranteed to capture the true proportion parameter in 95% of all samples. Okay, so if I take 100 samples, 95 of them are going to agree. So let's look at a little bit of math here. P stands for the population proportion. X stands for the number of successes. N is the sample size. And by successes, that means people who answer your question. Like I said, how many in this previous question, we asked how many kids smoked. The ones that raised their hand would be the X, okay? This is unknown, right? It is the mean, but we don't know it. So we have to look at our sample to try to figure this out, okay? So P hat is the sample proportion, and it is X over N, the success or yes, like did you do this or that, over the entire sample, okay? Q, now if you remember this from our last unit, we used P and Q in there. Q is 1 minus P, so Q is the complement of P. So if you want to think about it, well, never mind, I'm not going to do that. Okay, so this is approximate. Because we're going from a sample, correct? It will be normal, as in a normal distribution, if the sample size is large enough. Okay, and remember, P hat is an estimate of P. So basically, we're using our sample to estimate the population, okay? And one of the things we have to go back and look at, this is a little bit of review here, is standard deviation. Remember the formula for standard, we had an easy formula for standard deviation. Now we're going to kind of get a better one. It's P times 1 minus P over N. Another way you could say that would be P times Q over N. But if we put Q down, that's another letter. So you could think about it as 1 minus P. If you've forgotten how to put the radical in, a radical into your calculator is second square, and then to get a fraction, remember it's alpha y equals, okay? And remember the values of P right here. This we know. from data we collect. And this right there would be P. This is P hat. Notice there's a hat on there, okay? So let's look at one real problem and then we'll take a break. All right, suppose the truth is that 21% of high school students smoke. If we took a random sample of 14,041 high school students, the mean would be 0.21. Find the standard deviation. So there's our standard deviation, right? So it's going to be, right, P times 1 minus P. And remember, these two right here are going to add up to 1, correct? Over N, and that's 14,041 students. Okay, so that equals, take time to type it in, 0.0034. And I want to be clear, right? 21%, if that's what they give you, that means P equals 0.21, right? If there's this many, that's N, okay? The center of this normal distribution is at the truth about the population. That's the absence of bias in random sampling. The standard deviation is small because the sample size is quite large. So almost all samples will produce a statistic that is close to true P. In fact, the 95 part of 68, 95, 99.7 rule says that 95% of all sample outcomes will fall, that should not say vol, it should say fall, between. You calculate. So let's look at this. P equals, and here's a formula. This is one that you want to be able to come back to. If you want to write that on a piece of paper or highlight it or put it on an index card, of course you don't have to memorize it because you can use it, but you want to know what's available. So let's say we want to know the truth here. So the P is P hat, right? Plus or minus 2 times 0.0034. So P equals, if you type that in, you're going to 0.21 plus this, 0.21 minus that, you're going to get 0.2032. And you can pause this and type that in yourself and make sure that you get it. Okay, so 95 and 95% is within 2 standard deviations. So there's 0.032, 0.2168, and that's right here. And if you look at this and add the standard deviation on, we fall within 2 standard deviations. Okay, the vertical line is the true value of the population proportion P. So hopefully that makes sense. We will do some math with that to help out. But for now, just go back over this and we will have another lesson and then we'll have an assignment to go with it. Have a great day.